Lesson 12.2, talking about choices, tree diagrams, and the probability of something happening. Many of these in here are review again. We've already talked about probability. We've already talked about tree diagrams, although we used to call them factor trees. And we're going to talk about choices, what you can pick from, and what that means. And one of the common ways to do choices and tree diagrams and probability is to plan a meal and think about a lunch. What I mean by that is, if you walk into the lunch line and you have your first two choices, your first choice is you could have pizza or you could have peanut butter and jelly. That's choice number one. Then your second choice would be, after you've picked out your main dish, your second choice would be, do you want fries or chips or applesauce? So you could have fries or chips or applesauce afterwards. So if you pick the pizza, you could have fries, chips, or applesauce. And if you pick the peanut butter and jelly, you could have fries, chips, or applesauce as well. Then your third choice is your drink. Do you want milk or juice? And it doesn't matter what you have chosen so far, you can pick either milk or juice for each one. So there's a lot of possible paths that you can take to figure out your lunch. You could do pizza, applesauce, juice. Or you could do peanut butter and jelly, chips, and milk. You could pick any one of these paths to follow, and that would be your lunch. Now, this would be your choices. Choice 1, choice 2, and choice 3. Your tree diagram is what I've drawn here. Your tree branches, kind of like your factor trees that we did before. But now here's the new thing, and that's probability. What they will ask is they will ask you, what's the chance or the probability that you choose peanut butter and jelly, fries, and milk? So if I take that path and highlight it, if I go peanut butter and jelly to fries to milk, what is the probability that I'm going to choose that? And it's actually quite easy to figure out. You just count the number of possible paths you could take. 1, 2. That would be pizza, fries, milk, pizza, fries, juice. Pizza, chips, milk, pizza, chips, juice, and so on. Or you could just count the bottom. How many options are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have chosen one path out of 12 possible. That right there is our probability for having peanut butter and jelly, fries with milk. That would be a 1 out of 12 chance, or a probability of 1/12 of having that as your lunch. Another way to look at this is getting dressed. How many possible outfits could you have? And let's say you want to look at shirts and you want to have either a blue shirt or a green shirt. And with pants, do you want to wear jeans or do you want to wear like sweatpants? So that'd be jeans or sweats. And shoes, do you want to wear tennis shoes or sandals? Tennis shoes or sandals. So you could wear the blue shirt with jeans and tennis shoes. You could wear the blue shirt with jeans or sandals. The blue shirt with the sweatpants, do you want them with tennis shoes or sandals? And how do you want this to go? So all of these different kinds of tree diagrams would work. Now, probability then, you figure it out from this. There are some other questions as well as far as how do you go in or out of a building. I think in the journal pages they talk about a stadium. In a stadium you can only go in 3 gates, X, Y, or Z, and only out A, B, and C. You can't go in Y and back out. That doesn't work. You're not allowed to do that. So how do you go? Well, you can go in X and out A, B, C, or D. And you can go in Y or out A, B, C, or D. And in Z and out A, B, C, or D as well. So how many possible ways can you go in and out? Well, how many choices do you have for going in? You have 3. How many choices do you have for coming out? You have 4. So, anybody going in and out of this stadium could have 12 possible combinations of doors they could use. Now, obviously, they would only choose one of those paths, so they would have a probability of 1 out of 12 for choosing one of those paths. So that's what choices, tree diagrams, and probability comes down to. A lot of this is review. A lot of this we have talked about already. So if you need to go back and look that stuff up, feel free to. But this is pretty straightforward, and this will get you your information you need.